Well, thanks everybody for coming here today, and it's great for us to kick off your seminar series, or the kickoff of our seminar series too. I'm Denise Reed. I'm with the University of New Orleans, and I guess my official title in here, which you'll probably see on a slide in a moment, is I have been for the last couple of years the Senior Technical Advisor. I'm not in charge, I'm just an advisor, relative to Louisiana's 2012 Coastal Master Plan. This is the first in a series of seminars that we're doing at 4 universities across the coast to highlight not so much the plan, but some of the underlying analyses. We did some things that we think are new, we think are cool, and we want to both tell you about them and get your input. At the front of the room here, I just point this out, we have flyers for the other seminars in the series. I know you probably don't have time to travel across the coast like we're going to see all these presentations. There is the intent that they will be at least recorded in some way and posted and made available. So if there's a model that you're interested in and you can't get there, then let us know and we'll make sure that you get the information about the seminar, because we're actually giving the modelers a chance to talk about what they did, and you'll get the information straight from the horse's mouth. So that's at the front. Also at the front we have a few copies of the actual plan. But today, what we're going to talk about is not really the plan. Again, it's the underlying analyses. And because there is a lot of that underlying analyses, we're just going to focus on a couple of aspects of it today and cover the rest in the other seminars. So what I want to start with here, just a few introduction to this. We did the work that we did, and those that speak to you today are going to describe work that was done, modeling that was done in support of a planning effort. This was modeling for planning, not so much modeling for research. And so we started this process when we started thinking about what kind of models we needed to support the implementation of the plan. We started with the master plan objectives. And they're paraphrased up here and described more in the actual document, which is available on the web. And so these were the things that we were trying to analyze towards, if you like. These were the things that we were trying to get our minds around and think, well, if the state was trying to achieve an objective like this, what kind of information would it need to make a viable plan? So we put together a kind of I think I'd call it a leadership team with folks from the state, Mandy Green and Carol Parsons Richards and Natalie Snyder. Mandy and Carol are here today. Natalie had another meeting. I was like the technician, trying to technical and troubleshoot and kind of keep it all moving from the technical side. Elena Owens with Brown and Caldwell was really kind of on it day to day, working out what was going on, keeping finger on the pulse, making sure everybody in the team knew what was going on. But the real meat and potatoes of the work was not done by us. It was done by 7 different modeling teams. And those are the groups that are going to be presenting their work during this seminar series. And so it's not just the 7 people that are going to be giving the presentations. There are a series of over 50 experts involved in those modeling teams. This is just a kind of outline, just quickly. I'm not going to leave it up very long because we really want to get into the meat and potatoes of the models of the types of folks that were involved in this and the sizes of the different teams. And so what you see on here is that we have representation and leadership from the main research universities within the state, also from the private sector, and also from researchers in the public sector. And so really this wasn't just a state effort doing it. The state wanted this done, but really the work was done outside of state government and led by those who have worked on coastal Louisiana and these kinds of issues for a long time. We also had a technical advisory committee for this effort that met over probably the last 12 to 15 months, have had monthly conference calls with our smaller leadership team. They've been helping us troubleshoot some stuff. We've been flying things by them saying, what do you think of this? Should we go this way or that way? Those kinds of things. And again, these are folks that have worked on large-scale, difficult kind of ecosystem restoration issues in their own systems. Steve Ashby's worked a lot on the Upper Miss. He was formerly at the Engineering Research and Development Center in Vicksburg with the Corps. He's now at MSU. John Calloway works on the Bay Delta. Fred Sklar works on the Everglades, and Cy Simonstead works on Puget Sound and also some California issues. So these folks were kind of watching us and kind of really kind of helping us work things through on a regular basis. And so, we'd show them results and really just supporting, if you like, our leadership team, getting us some outside perspective on what was going on. One of the things that we were trying to achieve in this was not just to look at this project or that project, but to try and see how the whole system was responding to the different things that the state was considering doing. And so what this slide, don't worry too much about the arrows, but this is where you see these 7 different modules that we set up in order to accomplish this effort. The key part is that to achieve the outputs that we wanted to look at, it took all of them, right? There's not just one model that does it. They feed information from one to the other. Today, we're going to hear about the eco-hydrology model and the vegetation model. And then next Friday at UNO, the wetland morphology model and the barrier shoreline morphology model are going to be presented. Thursday the 23rd at McNeese, we're really going to talk about the ecosystem services ones over here, the upper trophic level modeling that we did. And then on Friday the 2nd at UL Lafayette, we're going to look at the storm surge and the risk models too. So over the seminar series, we're going to cover all of these. We're just looking at a couple today, but these teams were working to feed information back and forth of one another to produce the kinds of outputs that the state used to inform the development of the plan. I made the point earlier that this was modeling in support of planning, not modeling in support of research, probably very different from all the kinds of things that a lot of the graduate students here at LSU, and I know back at UNO, doing their work. It was challenging because the coast of Louisiana is very complex. We didn't just want to look at wetlands, we wanted to look at what Barrier Island's doing, we wanted to look at what was happening in the open water too. We wanted to look at the different aspects of the system. We also wanted to look at what was going on in terms of storm surge reduction, what was going on in rural areas, industrial areas, urbanized areas, all the kind of complexities of the coast. Looking forward 50 years, trying to think about multiple different future scenarios, not just one condition for the future, but multiple conditions for the future. And then we had to individually evaluate 210 restoration projects, 10 different types of them, 34 structural protection projects, 156 loads of different things had to be done. So this was not spending a lot of time focusing on one project and how it works and what it's going to produce. It was providing an analytical framework so that we could look at the pros and cons of doing this versus that. Not so much forecasting the future in a lot of detail, but having a way for the state to sift through and work out which of these various projects was going to lead them towards those objectives more than another. And we had about 18 months. In just a kind of quick overview of what we did with the information and how it came together before we get into the details of the models, we looked at, as we usually do in these planning efforts, the first thing we looked at is what happens in the future if we don't do anything else. So this future without action is what we call it. We use the models just to look forward, not to evaluate any project. What is happening to the coast and where is it going to go? And we looked at multiple futures for that. We'll talk about that in a minute. And then we tried to tease out, using the models, these different kinds of project effects that you see described here. The outputs from all of the models went into a planning tool, which we're not actually going to describe in the modeling seminar series. On the master plan website, there is an appendix that describes the planning tool. It's kind of an optimization scheme, and it's appendix, somebody help me, D? E. It's Appendix E. See, Elena knows everything that goes on in all the appendices. It's Appendix E, and so if anybody wants more information about what we did with the output, then that's a good place to look, and we can point you towards that later. And then there was a comparison of the different options that was conducted. A couple of times, this is just one thing, the last kind of thing here before we get into the details of the models, because we've asked the modelers not just to describe the mechanics of their models, but show you some of the outputs that they were generating. And I said a couple of times that we were trying to consider multiple different future scenarios. We weren't just saying, this is what we think sea level rise, for instance, is going to be, and going with it. We wanted to look at different kinds of ways of thinking about the future. And so we identified early in the process I was going to say 10, and on here there are 9 categories in here. 9 categories here of uncertainties, things that we didn't know how they were going to work in the future. Marsh collapse threshold at the bottom is really about how sensitive the marshes are to things like salinity change and inundation frequency. And so what we developed then was a set of conditions that we're considering moderate, and then a set of conditions that we're considering less optimistic. And you see, for instance, that sea level is higher in less optimistic than it is in moderate. Subsidence varies from one part of the coast to another. That's also described in a lot of detail in one of the appendices. But basically, in the less optimistic scenario, subsidence is always higher than it is in the moderate condition. And so you also see that there's actually less river resource available in less optimistic conditions. There is a difference in rainfall and evapotranspiration too. So that's just a little bit of context. Again, the details of this are explained somewhere in an appendix, and we can point you to the specifics, but you will see output today that talks about these 2 different scenarios. So we thought it was worth just showing that up front. Okay, time to get started. I'm sorry that took so long. So we're going to look at 2 models today, and our first presenter is Dr. Ehab Masaly from the University of Louisiana Lafayette. He has led a team of researchers, which he'll introduce you to during the talk. He's worked in Louisiana for a number of years, and I think has done a great job in a number of these planning efforts and really bringing the kinds of analysis that we can do in the engineering and fluid computational side to bear on planning studies. He's looked at the Cheniere Plain, he's looked at other parts of the coast, and he's also done a lot of work on the Mississippi River. So we'll start with Ehab, and then we'll move on to that, and then Yannicka Visser from the University of Louisiana Lafayette is later going to describe the vegetation module. And we'll keep questions right to the end, if that's okay. All right, no questions before we keep going? Right, good. Okay, so Ehab, over to you.